Alrighty. So we have permutations, the last lesson on permutation. With repeating objects and restrictions continued, you want to pay close attention because this is where it gets a little, not tricky, but if you don't pay attention, you won't remember or notice what I'm doing. It's not like it's hard, you just have to learn it. You haven't learned it before. All right. So example 1. Find the number of permutations of the letters in the word kitchen. Okay, so what I'm going to do is I'm going to go K, I, T, C, H, E, N. Remember I told you I always draw it out, and then if I have double ups, I'm going to write them below, or triple ups, I'm going to write them below. This just proves to me I have no doubles or triples, which is great, because that's all we've done so far. Now, the next thing to do is count how many letters there are and count it twice. The worst case scenario is you count the wrong amount of letters and get it wrong. That would just be terrible. So I like doing this because I like double checking. Okay. So you have 1, 2, 3, 4, 5, 6, 7. I'm super paranoid about not having the right amount, so I like literally count on top of them. And I'm like, then I count it again to make sure. Okay. So the letters K, C, and N must be together, not necessarily in that order. So they could be KCN, they could be CKN, they could be NCK, any of those, right? But they have to be together, not necessarily in that order. Now, whenever it says that you have to have it together, this is what I do. So I'm going to put my 7 blanks because I have 7 letters technically, right? First thing I'm going to do. 1, 2, 3, 4, 5, 6, 7. I have my 7 blanks. Now, when it says I have to be together, I always put them together at the front, and then I deal with them being in different spots after. So I'm going to hook them together. It's K, C, and N, so it's 3 letters. So I put a little box underneath, and I hook them together. So they're stuck together all the time. Okay? Now, if they had to be in the order K, C, N, you'd put a K here, a C here, and an N here, and you'd have the options 1, 1, 1. Correct in those blanks? But it doesn't say that. So I'm going to start off with the first blank. So the first blank, I have the options of K, C, or N, right? So how many is that? 3. But then what do? Remember, words are always non-repeating unless there's actually a repeating letter in it. Okay? So if it's not repeating, I always circle them. So I'm going to circle the K and say I kept the K here. So now for this blank, I'd have the C and the N left. So 2 options. Then I'm going to pretend I keep the N. So then I would have the C left. So 1 option. Okay? How many letters have I used up? 3. How many do I have left? 4. So how many do I have left for this blank? 4. And then I keep 1 there. So how many do I have here? 3. And then I keep 1 there. 2. Then I keep 1 there. 1. And then I keep 1 there. If you want to list the other options, I, T, H, and E underneath here, and then circle 1 and then drop 1 every single time and list that, that's fine too. Now, this would be the answer if it said that KCN have to be together, not necessarily in that order, in the front, or begin with KCN, not necessarily in that order. Okay? Did it say it has to begin with them? No, it just says they have to be together. So this is the catch, the extra step that everyone has to remember when it says they have to be together, but doesn't say they have to be in a specific spot. Okay? So they could be together here at the front. So it's like I have my 4 letters here, and they're here at the front, right? So these 3 letters are connected right here. Or I could move them between these 2 letters, couldn't I? And it would make still another letter, another word where they'd be together. Or I could put them between these ones, or I could put them here, or I could put them at the very back. And they'd all still be together, but not in the same as here, right? So how I draw that is I go, okay, they could be here, which is one way. You here at the front, which is one way. Or they could be between these 2, right? Which is 2 ways. Or I could pick all 3 of these letters up and put them between these 2 letters. Or I could pick all these 3 letters up and put them between these 2 letters. Or I could pick all these 3 letters up and put them at the very back. Correct? They would still all be together. Are they still all together? Yes, and they're making different words, correct? Because you're taking those 3 letters and moving them. Okay? So all we have to do is remember to times by all the other options. So how many options do we have? This is one option. Everyone forgets about this option. So they'll tell me 4. 1 option, 2 options, 3 options, 4 options, 5 options. So we have to multiply by 5. Not 5 factorial, 5. It's always one more than this number. So if it's 4 here, it's going to be 5. If it was a 3 here, it's going to be 4, right? Because it's always one more. Now, how could we write this as something nice? Because it's an answer. They can write this as, you could go 3 times 2 times 1 times 4 times 3 times 2 times 1 times 5. Absolutely, and get an answer. The other way they sometimes put together is 3, 2, 1 is what? 3 factorial. And then we have 4, 3, 2, 1 is 4 factorial. What happens, though, if I take this 5 and join it with it? It would be 5 times 4 times 3 times 2 times 1. So what would that be? 5 factorial, right? So I could literally just write this as 3 factorial, 5 factorial. Or what is that in math-wise? 720? Yeah, 120 times 6. Okay, do you see the catch there where it says they have to be together? You put them together, I always put them together at the front, and then I move them between all the rest of the letters that are left, because they're still together, right? But if it said together at the front, you wouldn't do the moving, okay? You'd be done, because they were together at the front. Difference. Number of permutations, arrangements where order matters, of the letters in the word kitchen if the vowels must not be together. Okay, key word here is not together. Okay, we're going to pay close attention. Now, if I say to you, how many students are in this school but not in this class? What's the quickest way to find that out? Go to each classroom and count them. Well, there's not all of them here today, but, or would I say ask for everyone's lists, class lists at this very moment in time and add up all the people who are not in this class? Would that be the fastest way? What would be the fastest way to figure out how many people are not in this class but are in this school? Yeah. Right. Find the total amount of students. Just go to Mrs. O. How many people go to this school? She tells you. You count the people in this classroom, you subtract them, and you know how many people are not in this class. Right? The fastest way. That's the only way to do these. When it says the vowels are not together, what you do is you do the total ways you can rearrange kitchen. No restrictions. No, these have to be together, these can't be together, anything. Total, no restrictions, just like the total amount of kids in this school, right? So let's do that first. So the total of ways I can rearrange kitchen, 1, 2, 3, 4, 5, 6, 7. How many letters do I have for the first one? 7 then? Which is just 7 factorial, right? Do you agree? So that's the total maximum ways I could rearrange kitchen and make new words, right? Now, like I said to you, what way can I determine how many kids are not in this class, but are in this school, right? I took the total amount of students, went to Ms. Zohe, said, hey, how many students? She says, blah, blah, blah. And you go, hey, Lepp, how many are in this class? And I say, blah, blah, blah. And you subtract them, and it's really fast, right? So what we're going to do is we're going to do all the ways we can rearrange kitchen minus all the ways the vowels can be together. If you subtract off all the ways the vowels can be together from the total, what's left over? All the ways they can't be together. Okay? So you do total ways of rearranging kitchen, and then you subtract off from that all the ways the vowels are together, and then what's left over are all the ways they can't be together. That's the only way you can do these without having to do like crazy amounts of cases. Okay? So we're going to subtract off the vowels together. So how do we make the vowels together? Well, we have to figure out how many vowels there are. I and E are my 2 vowels. How do we make stuff be together? Just like the exact example for previous 2. So you go 1, 2, 3, 4, 5, 6, 7. And I need to hook these first 2 together because I'm going to put the vowels together, right? How many options do I have for the first blank? 2. because I have the I or the E, correct? Then I keep one there. So how many options do I have left for here? One. Now, I've used up 2 letters. I have 5 left, correct? So I'm going to have 5 for this one, then 4, then 3, then 2, then 1. So is that all the ways I can keep the vowels together? No, I have to move those vowels between the rest of the letters too, correct? So this is one way. Or put it between these 2 ways, 3 ways, 4 ways, 5 ways, 6 ways. So I have to times it by 6. Because it's always one more than this. And this is a 5, right? So 7 factorial represents the ways to rearrange kitchen, minus 2 factorial times 6, 5, 4, 3, 2, 1, 6 factorial. Make sure you put this in brackets if you're going to put in your calculator all at once. $3,600. So there's 3,600 ways that the vowels cannot be together. It's the only way you can do not. If you didn't do it that way, you'd have to like do cases. Okay, well, I'll put one vowel in the front and one vowel in the third. One vowel in the front, one vowel in the fourth, one vowel in the front, one, and then you have to go, okay, one vowel in the second, and then one in the fourth, and the second and fifth, and second and sixth, and then, okay, one vowel in the third, and the first, okay, I've already done that case. Third and fifth, it'd be horrible. It would be horrible. This is the only way that's relatively decent. Okay. Example 2. In how many ways can all the letters of the word oranges be arranged if, so oranges, O-R-A-N-G-E-S, no double ups. 1, 2, 3, 4, 5, 6, 7 letters again. All the letters. We're rearranging all letters, not 4 of the letters, right? All of the letters. So there's no further restrictions. 1, 2, 3, 4, 5, 6, 7 blanks. How many letters do I have for the first one? 7, then. So it equals 7 factorial, which is, yes. You try the next 2. The catch on this one is the vowels must be together in the order O-A-E. So they're together and they have to be in the order O-A-E. Okay? Try it out. The first letter must be an N. So we have to have an N here. There's 1. Then how many options? 6, then 5, then 4, then 3, then 2 letters left, then 1. 720? Is that what it is? Because it's 6 factorial, right? 6 factorial times 1, which is 6 factorial. The vowels must be together. 1, 2, 3, 4, 5, 6, 7. They must be together, so I hook them together. My only options are O, A, then E. So I have 1, 1, 1, because that's all that can be there. Then I have 4 left. 3, 2, 1. Does it say together at the front? No. So I have to move them. They can be to here, which is 1 way, or here, which is 2 ways, or here I can move them, 3, or here, 4, or here, 5. So times by 5. So I'm going to get 1 times 1 times 1, which is 1, times 5 times 4 times 3 times 2 times 1. So it's just 5 factorial, which is 120. So in how many ways of the arrangements of the word brains are the vowels together? So we have B, R, A, I, N, S. 1, 2, 3, 4, 5, 6 letters. 2 vowels. So we do 6 blanks. 1, 2, 3, 4, 5, 6. We have to have 2 of them together. Put them together. Then I have, it doesn't say vowels together in a certain order, does it? So I have A or I here, so 2. Say I keep A there, then I'd have I here, so 1. And then I have 4, 3, 2, 1. And I have to remember, it just says together. So here's 1 way, or 2, or 3, or 4, or 5. So I'm going to get 2 times 1, which is 2 factorial. Or instead of saying 2 factorial, I could just say 2, right? Because 2 times 1 is 2. And then I have 5, 4, 3, 2, 1, 5 factorial. So it's going to be 240. Example 4, we're going to do 2 ways. We're going to do it the exact way this is, and then we're going to make even number of girls and boys and see what happens. Difference and change, okay? So, in how many ways can 3 boys, or 3 girls, sorry, and 4 boys be arranged in a row if no 2 people of the same gender can sit together? No 2 people of the same gender can sit together. So how many do we have total? 7. We're arranging them. So is it a permutation or a combination? Does order matter or not matter? It's permutation because you're arranging them, right? You're saying this person can't be beside this person. The moment you say that, you're arranging them. The moment you're arranging them, order matters, right? You're saying they can't be together, right? When you're lining anything up in a specific order, it's a permutation. Order matters. So we have 7. We're going to line them up. 1, 2, 3, 4, 5, 6, 7. No girls or boys can be together. So what does that mean? If no girls and boys can be together, what do we have to start with? A boy. If we start with a girl, at some point we're going to end up with 2 boys stuck together because there's more boys than girls. Okay? If we start off with a girl, we'd go girl, 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 oh crud, 2 boys at the back, right? So we have to do boys first. So this would be a boy, this would be a girl, this would be a boy, this would be a girl, this would be a boy, this would be a girl, this would be a boy. Okay? So I'm going to do the boy ones first. How many options do I have for this one? 4. Then I leave a boy there, right? That's the point. If you don't leave a boy there, you're just starting off with girls again. You're going to have to put the boy at the back and have 2 boys. It's problematic. Okay, then I have how many boys for this one? Then I leave 1 there. 1. Now if I do the girls, I'm going to have how many options for this one? 3. Then I leave a girl there. 2. Then I leave a girl there. 1. And I just multiply them. Now if you look at all the green ones, 4, 3, 2, 1, what does that make? 4 factorial. So the green ones make 4 factorial. And what do the blue ones make? 3 factorial. 3, 2, 1. So it's going to be 24 times 6, which is what? Now at the bottom, I'm going to change it. Or you can do it at the top because you actually have quite a bit of space at the very top. I would just arrow and arrow up. And this is going to be your challenger type, just making it a little harder. Okay? Instead of 4 boys and 3 girls, I'm going to do 4 boys and 4 girls. So it's just going to be an extension of this one. Same question. Except 4 boys and 4 girls. So now we have 8, right? Same rules, no boys can be beside girls, no girls can be beside boys. Okay. I'm going to do by show of hands. Who would put a girl in the first blank? Who would put a boy in the first blank? Okay, let's try again. I have 3 people and, well, 2.5. That's kind of like this. So I don't know if that's just grabbing air and oxygen in hopes for some oxygen levels or what you're doing. Okay, so for this first blank, would you put a boy in it? Put your hand up. Start with a boy. Who would start with a girl? Who has no freaking clue what to start with? Yay! Okay, so the catch is most of the time you guys are not normal. You're really awesome, but normally I'll have half the class put their hand up for starting with a boy. Well, about quarter of the class put their hand up for starting with a boy, quarter of the class put their hand up for starting with a girl, and the rest you kind of just sit there and go, I don't even want to answer because I'm not sure. Let's think about it. So I'm going to start with a boy first. Let's see. So we'd have a boy, then a boy, then a boy, then a boy. Well, I don't know why I tried. That's a girl. So then a girl back here, girl, girl, girl. Okay? So I have 4 boys, leave one there, 3 boys, leave one there, 2 boys, leave one there, 1 boy, leave one there. Here I have 4 girls, leave one there, 3 girls, leave one there, 2 girls, leave one there, 1 girl, leave it there. So now I have, with the reds, 4 factorial, and with the blues or blacks, 4 factorial, right? What's the catch? Yeah. You could start with either one. That was my point, but it didn't come across at all because you guys, none of you raised your hands. Well, 2 of you did, but that's what it. And then the second time I asked it, those 2 didn't raise their hands anymore. So I kind of like actually went down in numbers instead of increasing. The catch on here is people will do this for a quiz. They'll go 4 factorial, and they're like, done. But they forget that you could also have or, which means plus. You could have girl, boy, girl, boy, girl, boy, girl, boy. This is different than the last one just because there's an even number of girls and boys, right? The last one we could only put it in a specific way because we had less girls. So then it would be 4, 3, 2, 1, 4, 3, 2, 1, which is 4 factorial, 4 factorial. So instead of adding these like this, what could I have done? Instead of going 4 factorial plus 4 factorial, 4 factorial, what could I do? Yeah. Nope. Nope. I'm looking for something like super simple. Like 4 factorial plus 4 factorial, 4 factorial. How else could I do that? Yeah. Times the first one by 2. So I could just go 4 factorial times 2. Either way is just fine. I don't know what the answer to that is, though. What is the answer? Okay. You have 6 actors and 8 actresses are available for a play with 4 male roles and 3 female roles. Actually, I'm going to skip this one. It's more of a combination. Flip to the next page. Okay. This is where life gets a little bit harder, but it only gets harder in the fact that you have to remember to divide by factorials when you have double ups and triple ups, okay? It doesn't make it substantially harder. So far, all examples we have had different letters, but as soon as we have words with letters that repeat, we have to account for that by dividing by the total number of arrangements by the number of repetitions. For example, arrangements of the letters of the word Peter. So if I do Peter, it's P-E-T-E-R, right? We have those double ups. So remember I told you if you have Peter, and then I tell you to close your eyes and I swap the 2 E's, what do you still have? Peter. It didn't change, right? So if I just did 5 factorial, which is what I normally would have done, to rearrange Peter, I'd go, I have 5 letters, then 4, then 3, then 2, then 1, which is 5 factorial. You'd be correct, but you'd also be counting the Peter and Peter combination that are the exact same word, right? If I have Peter with the 2 E's in the spots and I tell you close your eyes and I swap the 2 E's, put them back in the same spots again, right? It would make the same word Peter, correct? So you couldn't be able to tell the difference between them two. It wouldn't make actually 2 new words. That's why we divide by 2 factorial in the bottom. because that's just going to take away the double up words that look exactly the same when you swap the E's. Does that make sense? So you have Peter with these two E's here, and I tell you to close your eyes, and I go like this and tell you to open your eyes, and it still says Peter. It's not a different word. So you always just need to divide by the factorial of how many extras you have here, which will make sense in a second. So a set of n objects with A of one kind that are identical, and B of a second kind that are identical, and C of a third kind that are identical, you'd go n factorial over A factorial, B factorial, C factorial. So how many different 10-letter arrangements can you make of the letters of basketball? Okay, here I swapped the two L's at the back. They're very different. Like this is basketball and this is basketball, but I took these two L's and swapped them for the second one. Can you tell? Absolutely not, right? You can't tell. Okay, actually, the first one I had these two B's here, and the second one I swapped the two B's. Could you tell? Does it still say basketball? Yeah. So that's why we divide off. We still do the same way. We still put the blanks of how many letters there are, and we still do the factorial all the way down, but we just remember to divide by those factorials at the end to take out those words that look exactly the same even though you swap the L's, for example. Okay? So, basketball, B, A, S, K, E, T, B, A, L, L. The reason why I do this is I know at the very end, I'm going to have to divide by 2 factorial, 2 factorial, and 2 factorial for the 2 B's, the 2 A's, the 2 L's. Could I just sum that up as 6 factorial? 2 factorial times 2 factorial times 2 factorial is 2 times 2 times 2, which is 8. Okay? 6 factorial is 720. So if I divide by 2 factorial, 2 factorial, 2 factorial, I'm dividing by 8. If I divide by 6 factorial, I'm dividing by 720. Would I get the same number? No. So you can't put them together. You can only put like letters together. Okay, so 2 factorial, 2 factorial, 2 factorial. So basketball, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters. 1, 2, 3, 4, 5, 6, 7, 8, 10 letters. There's no restrictions on it. I just want to know how many words, different words can you make, how many different 10-letter arrangements can you make from basketball? So I'd have 10-letter options for this one, then 9 for this one, 8, 7, 6, 5, 4, 3, 2, 1, which is what we did before. The only difference is now on the bottom, we're going to divide by if there's doubling letters. So I'm going to go 2 factorial for the A's, and 2 factorial for the L's. And you have to put them in brackets. Okay? So how could I put that in my calculator? I could go 10 factorial divided by 2 factorial, 2 factorial, 2 factorial. If you put it in all at once, guys, you have to put it in with brackets. If you don't put it in with brackets, what your calculator thinks you're doing is 10 factorial divided by 2 factorial, and just 2 factorial, and then times by 2 factorial times 2 factorial. Like it's going to make it bigger. It's not going to divide by all 3 of them. Okay? So you have to go 10 factorial divided by 2 factorial, 2 factorial, 2 factorial in brackets. Or else it's just going to divide by the first 2 factorial and times by the next 2. Okay? Which won't get you the same answer. So you should get 453,600 words. Now, if all of the letters had been different instead, say they'd all been different, then it would have been 3,628,800 words, right? But because there was doubling up of letters, we have to divide by those. We have to divide by 2 factorial, 2 factorial, 2 factorial. And because of those doubling up of letters, it went from 3 million words to 453,000 different words, right? Because with those 2 L's at the back, if I swap them, it's still basketball, right? Okay. You try this. Try Aardvark, Vancouver, mathematical. Okay, Aardvark, 1, 2, 3, 4, 5, 6, 7, 8 letters. A, R, D, V, A, R, K. 1, 2, 3, 4, 5, 6, 7, 8 letters. So I'm going to have 8 factorial on the top because I'm going to have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And on the bottom, I'm going to have 3 factorial, 2 factorial, because you have 3 A's and 2 R's. So 3,360. Now, I want to prove to you that the doubling of letters doesn't matter. So let's say I look at Vancouver and I say to you, how many ways can I rearrange Vancouver, which I didn't do this before, so you're not going to have the same answer as me, where the V's have to be together. Okay, the V's have to be together. So I have V, A, N, C, O, U, V, E, R. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to say the V's have to be together. So I'm going to hook them together here. Okay? And some people will say, well, there's only one way and one way. It's V's. Like, what does it matter? You treat them like they're different letters completely, because what you're going to do at the end is you're going to divide off those doubling ups. So you don't have to worry about it, okay? So how many options do I have for the first one? 2 V's. So 2. Then I keep another V for here because I left one there. So 1, right? And then I have 1, 2, 3, 4, 5, 6, 7 letters left. So 7, 6, 5, 4, 3, 2, 1. And then I'm going to times by 8 because I can have them here one way, 2, 3, 4, 5, 6, 7 are at the back, 8, right? So it's the exact same steps as we did before. We just treat the V's like they're different. And then what do we do at the very last step? Divide by 2 factorial. So we're going to get 2 factorial, 8 factorial, divided by 2 factorial. Okay? So you do all the same steps. Everyone gets thrown off when there's doubling letters. Just treat them like they're different and just divide them off at the end. Don't worry about it. Don't stress yourself out. Okay? So then this one would just end up being 40,320. You guys would have, however, gotten 9 factorial divided by 2 factorial. So your answer would have been 181,440. And then mathematical, M-A-T-H-E-M-A-T-I-C-A-L. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 factorial, because it'd be 12 times 11 times 10, blah, 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 divided by 2 factorial for the M's, 3 factorial for the A's, 2 factorial for the T's. And so you get a really large number. 19,958,400. We're going to deal with these 2 tomorrow, and I'm going to give you the rest of your assignment. It's still out of that same page. I know, fun. And then we start combinations tomorrow. We just finished these last 2 examples and then combinations. So your homework is still page 524. But now we can just do more questions. So number 5, BDF. $10, you can do B and C now. 11. Now, what if it says identical vehicles? What if it says same model now? Same model means you can't tell the difference. It's like having a B, a B, a B, a C, a C, a D, 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 right? So you treat the top like normal. You just have to remember that at the end, you have to divide by 3 factorial for the 3 black cars and 2 factorial for the 2 red cars, right? That's the only difference. That's it. If it says different model, you don't divide by the factorials. If it says same model, you divide by the factorials. That's it. Don't let the the doubling up repetitions throw you off. You're just literally dividing them off at the end. That's the only extra step, okay? Throws people off all the time.